Okay, now we're going to look at the margin of error when we're comparing percentages. For example, a percentage voting National with the percentage voting Labour. What's the difference in the percentages between the two groups? Do they overlap? Can we say that one is almost certainly going to get more of the vote than the other one? We start off by comparing two dependent groups in a sample. In other words, it's the same sample, same question, but there are two different categories of response. So we would be asking the same people the same question, who are you going to vote for? And there are different categories of response. So here's an example. Can we say that National is very likely leading Labour in support? So if we look back at our data, we've got National with 47 plus or minus the 3.1% margin of error, and we've got Labour with 32 plus or minus the 3.1% margin of error. If we look at the difference in the vote, 47 minus 32 is 15, a 15% difference between the point estimates. Over here, and you can highlight this, it says to find the margin of error of the difference. It's simply 2 times the margin of error. Because they're both from the same sample size, n equal to 1,000, the margin of error is the same. So in this case, it's okay to double that, so it'll be 15% plus or minus 6.2%. So what does that tell us? That tells us that the difference in support is likely to be between 15 minus 6.2, which is 8.8%, and 15 plus 6.2, which is 21.2%. So the sentence, so we are 95% confident that National leads Labour because 0 is not in the interval. National could, let's change that to lead, could lead by as much as 21.2% and as little as 8.8%. But still, we can clearly see that the difference is positive, so that National is always in the front. Right, now we're asked to compare two independent samples or groups within a sample. So this might be two different samples, one taken in 2015, one in 2016, or it might be two groups within a sample, so what the males prefer and compare that with what the females prefer, two independent groups. Remember, the one above was for the same people with the same question but different response categories. This one could be different samples from different year groups, or it could be two distinct groups taking the sample. Right, what is the MOE of women in the Colmar poll? Okay, so this is referring to the first page of the worksheet. Remember, there were 1,000 eligible voters, and we're told that if we're not told directly how many men and women there are, it's okay to assume, you need to write this down, state your assumption, assume a 50-50 split. So we will assume 500 women, which would mean the MOE would be 1 divided by the square root of that. using the rule of thumb, which is 0.0. Once again, we don't actually know what the P value is for women, so we've just used the rule of thumb margin of error, which usually gives us the widest possible margin of error. Right, so here we go. So for females, we've got 44% in favour of national. That'll be plus or minus the 4.5 margin of error from the question above. Oh, actually, let's take that a bit slower. The males, 51%. Now notice it says 40% of the respondents were female, so 40% of 1,000 is 400. So if we do the rule of thumb MOE for the females, and we'll change it to a percentage, and similarly the rule of thumb margin of error for the males must be 600 males, 4.1% to 1 dp. So we go back up over here. Right, now we're looking at the difference. I can see there's a raw difference in there of 7%, plus or minus. Now this time the margin of errors are different, and if you grab a highlighter and highlight this box here, it tells you for the margin of error of difference where you have two distinct groups or two different samples, we work it out by doing 1.5 times the average of the two margins of error. So if we do the working down here, we want it'll be plus or minus 1.5 times now the average. If you want to average, add the two together and divide by 2. So you can work that out, 6.825. So we might round it to plus or minus 6.8%. We're running out of room here, and you probably are too, but so that gives me a 95% confidence interval of males preferring national So we want 7 minus 6.8 and 7 plus 6.8. Once again, since 0 is not in the interval, we can claim with 95% confidence that men favour national more than women. So the men favour the national over women by as much as 13.8% bigger percentage, or the percentage bigger might only be a gap of actually 0.2%, 2% more than a female does.